Today we're going to continue our conversations with transformations, looking specifically at rotations of 180 degrees, and a lot of times the rotations of specific numbers have really nice results for them. So if we look at the example number 1, the picture below shows what happens when there is a rotation of 180 degrees around center 0. And what I want you to notice is that the image and pre-image lie on the same line, and that line goes through the point of rotation. And one way you can do this at home, just to check what's going on, is you can actually flip your paper 180 degrees or 90 degrees, and what you'll notice is that the orange highlighted Q is above the blue highlighted P on the right-hand side. And so when you bring it back, you can see your pre-image and where the image would ultimately be. Okay. Other important aspects of this is that angles maintain themselves if I have intersecting lines, vertical angles are formed, and we know vertical angles are congruent. So we maintain the ability to have distances away from the origin. We maintain the angles that they were, even with the rotation. Our next example says, the picture below shows what happens when there's a rotation of 180 degrees around center O. Center O happens to be at the origin, so we can sort of come up with some really nice results, combining the fact that we rotated 180 degrees and that our center point is the origin. Okay, and in these situations, sometimes it's really nice if you can use a transparency just to get an idea of what's going on. So I come out with the transparency. I'm going to trace over OP and PA. I'm going to make sure that I have my center point marked. And I'm even going to give myself a little gauge line to know when I've actually rotated 180 degrees. Put my pen on the center point and rotate. And now that this is all lined up again, I now have the rotation where P prime is again still on that same exact line. You can see that it maintains the slope, and A stayed on the x-axis. So like I said, there are some really nice results. The question I would ask though is there a short way? Can we view this truly as a function? Maybe be able to map one point to another, just knowing that it's a center point at the origin and a 180 degree rotation. So let's just look. P, the pre-image, was the point -4, 3, and that seemed to map to the image P prime at 4, -3. If I look really closely at this, the -4 became a positive, and the +3 became a negative. So my idea is I negate the x and y. And so just double check it. Well, A is -4, 0. That maps to A prime, which is 4, 0. The negation of -4 is +4. The negation of 0 will still maintain 0. So I kind of have an idea that when I have a rotation about the origin of 180 degrees for x comma y, the result will be -x and -y. And we can continue to check this and then ultimately make a declarative statement. So now we're on to our exercises or examples. Using transparency, rotate the plane 180 degrees about the origin. Let this rotation be rotation with this little tiny 0 subscript. What are the coordinates of the rotation, little subscript 0, of 2, -4? This stands for the origin, which is why I've highlighted everything in orange for you. And so again, the quickest way to do this is to center this up, rotate 180 degrees, and realize now that this is -2, +4. Okay, so if you're at home, you can easily do that with your own piece of graph paper. If you want to see it done with a transparency, you start off, you've got your -2 or 2, -4. Make sure you have your origin marked, a guiding line, and then rotate it. and there it is. And it maps to -2, 4. So we go back. Let's just check our rule. Our rule was if I rotate about the origin 180 degrees, I would negate each coordinate. So the end result should have been -2, +4. And is that what we ended up with? Yes, it is. So this got plotted here after a rotation of 180 degrees. So we could call this like P and P prime, and this is -2, 4. Okay, let's continue. Next problem. It says let the rotation be the rotation of the plane 180 degrees about the origin without using transparency. So they're really asking us to have made a connection between the pre-image and the image. The original point is 3, 5, so rotation about the origin of 180 degrees for the point -3, 5. Where should that go? If I negate each value, I have 3, -5. So it should be right here. Bless you. Now you can always check your work with a transparency. So we'll take it, put this on the origin, put this on 3, -5, and rotate it about the origin. And I see it does line up exactly where I had predicted. So I'm sort of solidifying my understanding that when I rotate 180 degrees around the origin, I negate each value x and y. Okay. Number 3. Let the rotation be a rotation of 180 degrees around the origin. Let L be the line passing through the point -6, 6. So I want to look at this point -6, 6. And in fact, we can sort of view a line as a series of lots and lots of points, and where would they graph to if I were to rotate them 180 degrees around the origin. So I'll add one more here. And so before we even start talking about the line, I think about where these would graph. If this is 3, 6, that would mean it would go to -3, -6. And the -6, 6 would go to +6, -6. And what I'd see is that I have a line just like that. Now, if you want to check, again, it's really wise to check these things. You can always check transparency, rotating your paper. So we have this at the origin. We have our line. And then we just have to rotate it. And it does match up. Some other really, really nice features about this is that they maintain being parallel to the x-axis, and line L is parallel to line L's image. Okay, so maybe that only works for horizontal lines. Let's look at the case where we have a vertical line. Here's the point 7, 0. The line itself would be x equals 7. When I rotate this around, where does it go? So I'm going to show you, if you were at home, rotate the paper. Now the vertical line is at -7. So here would be my rotation of 180 degrees or about the origin. This line is x equals -7. Again, I maintain the fact that the two lines are parallel, not only to each other, but the original line that they're parallel to, which is the y-axis. And so I'm beginning to have an intuitive understanding of what happens when I rotate around the origin 180 degrees. I'd also have this point, -7 and 0. Okay. Continuing forward. Let the rotation be around the origin at 180 degrees. Let the line pass through the point 0, 2. So again, we're kind of sitting on one of the axes, which is different than the original one here, 0, 2. What would happen if we rotate that? I think we can start to predict exactly what would happen. It would rotate around, it would maintain the ability to be parallel. And its result would be the line y equals -2. This began at y equals 2. The point 0, 2 would negate the 0, negate the 2. So this point would be the image of 0, 2. Just one last example like this. I have a line. It's going through -4, so this would be the x equals -4 line. Once I rotate it around, once again, we do have those parallel lines. If I think about it as -4, 0, where does that go? Once I've rotated it, I should get a +4, 0. So we've maintained the identity that we've discovered at the very beginning of our video. And so now we get to a line, it's not either vertical or horizontal. And will this work the same way? That's the big question. Will this work the same way? And so one thing you might want to take note of is the exact slope of your line. So it looks to me like we start here, we go up 1, 2, 3, 4, 5, and over 1. So my slope is up 5 over 1. We're just going to keep that to the side, maintain it. Because if slopes are equal, then we know we have parallel lines. So I'll put my transparency on this. I'll mark out the origin. I'll also mark out the line. It'll tell me when I've rotated 180 degrees. There is 180 degrees. The lines do look parallel, but maybe we should count. Let's find, okay, here's a spot. 1, 2, 3, 4, 5 over 1. So we do end up, is line L parallel to the rotation? Line L is parallel to rotation L, to answer the question that we're being asked. Okay, and then finally, we get to one where there is no grid. And so what can happen is you might have to put your own little grid on there to be able to rotate it. And the result still maintains that parallel nature. You can absolutely see it when you look at the transparency. So we'll double check our work. Here's my line on the transparency. Here's my point. Rotate it around. And those lines are now parallel. Okay, brief summary, pause the video, kind of look at all these. What is a rotation 180 degrees? What is the theorem? How does it map? There's some rules involved in this. We talked about them all along. What are the things that you need? We identified at the very beginning that they lie in the same line, so they're collinear. Thank you for your time.